Chapter 1, Section 3, Points, Lines, and Planes. A point is a location with no size. We usually draw it using a dot. And I know somebody's gonna say, but Ms. Claypool, I could get out a ruler and measure that dot. Totally true, but we don't, the dot is just a representation of something that has no size. But if it had no size, I couldn't draw it. So it's a representation. We are going to call that point P, and we would usually either say point P or just P, okay? A line is a series of points that extends in two opposite directions without end. So without end means we have to add these arrows on the ends that show that it keeps going on forever and ever, even though we're not going to keep drawing forever and ever. And there are infinitely many points on this line, but I'm going to label 3 of them. So let's say that that's A, that's B, and that's C. Those are kind of handles on this line. And let's name this line. We're going to name this line L. That's a cursive L, so you don't think it's a number 1. L for lines is kind of like Kim or Park here in Korea. It is like the most common line name, just because sometimes we're not very original. So if you wanted to talk about this line, you might call it line L. You might call it the line that connects A and B, so you would just say line AB. You might call it line AC. You could call it line BC. So you can use any 2 points on the line to refer to that line. You could even use 3 points, but it'd be kind of silly. Okay, a plane is a flat surface that has no thickness. A lot of times we draw a plane using like kind of a rectangle, and a plane has infinitely many points on it. I'm just going to call these A, B, C, and D. And I'm going to name this plane P. So we could say just plane A, B, C, D. Or we could call it plane P. Let's see, points on the same line are collinear. So if we look at this line up here, collinear, co means like sharing, so you have co-workers or colleagues, also has co in it. This and linear means line, so this line here has some points, a whole bunch of points, but we only labeled 3. So for example, on this line, points A, B, and C are collinear. Okay? Coplanar is the same thing except on a plane, so it's a bit of a shame I used the same letters. That was kind of dumb. Over here, these points are all coplanar. Actually, these points would all be coplanar too, but let's talk about these points. So over here, I'll draw a little up there. Points A, B, C, and D are coplanar over there. Okay? All right. Last definition is a postulant or an axiom, and what that is an accepted statement of fact. So we have a few things that we just accept are true, and then we build math from there. So here are a few postulates. Through any 2 points, there exists exactly 1 line. So let's say I have 2 points. I'm going to call them A and B because I completely lack originality. If I want to connect those points with a straight line, there's only one way I can do that. I should have a ruler, but I don't, so pretend with me that that line is straight. Okay, so through those 2 points, there's only one straight line that connects them. Next up, postulate 1.2. If 2 lines intersect, they intersect in exactly 1 point. Lines are straight in geometry, unless you're doing something like geometry on a ball or something, but we're not doing that. We're talking about planar geometry. So, lines are straight. If you have 2 straight lines, and they're not parallel, they're going to intersect sometime. And that intersection is going to be a single point. P. Why not? Oh boy, I'm not very good at drawing, so you're going to have to bear with me. Okay, I'm going to try and draw 2 planes that are going to intersect. So let's say that that's a plane. And let's say that that's a plane. Let's see. These guys are going to intersect right here. This is where they cross in exactly 1 line. And you could extend that line because the planes are also going on forever in either direction. I can't draw forever. All right, last postulate of the day. Through any 3 non-collinear points, there exists exactly 1 plane. So if you've got 3 points and they're not all on the same line, then there's exactly 1 plane that passes through all 3 points. As a matter of fact, this piece of paper is the plane that passes through these 3 points. If you want to illustrate this in space, what you can do is you can take 3 fingers and hold them up and balance a sheet of paper. It's not the world's best example because my paper is kind of limp and falling off, but as you turn your 3 fingers, that changes how your piece of paper would be oriented. I don't know how well you can see this, but you can try this at home. Alrighty, kids. There's not a do-it-yourself in these notes, so what I'm going to do is attach a PDF file with some problems, and you're going to do those problems as part of your homework.